So good afternoon, dear students. Welcome to another session on Introduction to Data Structures and Algorithms. Module 4. Today, we are going to discuss very important topic. Very important. Note down in your books. It is very important topic that we are going to discuss today. Very important. What is that? Double-ended queues. So, that means a queue which have both insertion and deletion can be done at both the ends. So we call it as double-ended queues. Okay. So before that, I would like to have a small announcement. Assignment 7 is already announced. 29th June, that is Tuesday, by 5 o'clock you need to submit. Okay, that is the deadline. And again, it's a 10 marks question, 10 marks assignment. You have 5 marks. Each question will carry 2 marks. Okay, so do well. That's your side, some work during, weekends, Saturday and Sunday. Okay, checkpoint. What we have done yesterday. Yesterday we have discussed about priority queue. What is a priority queue? I think you know very well. It's a type of queue where each element is given some priority number. This priority number is very much helpful in order to delete the element, in order to take out the element. So that is the definition. And what is the order of deletion if two or more elements have the same priority? So this is the question. If two or more elements have the same priority, then the delete as per the order in which they are added. That is first in, first out. So if both are having A and B, both are having same priority. If B has come before A, then A will be deleted later and B will be deleted first. So first come first serve. So this is what yesterday we discussed. A small review of what we have discussed yesterday. Coming on to today's topic, double-ended queue. By looking at the diagram itself, you will understand double-ended queue is a unique special type of queue that has both the features of inserting and deleting in both the ends. So inserting and deleting of elements in both the ends, so is what double-ended queue is all about. And of course you have to implement, you have to write a C program and you have to implement this, right? And some question before we go further. In which situation double-ended queues are used? Remember, dear students, especially whenever you are working in a multitasking, multi-processing environment. So double-ended queues are very important. So double-ended queue, or in short you call it as DQ, is used for implementing a steel job schedule algorithm, and this algorithm helps tasks scheduling for multi-process. So for many processes, if they are processing, so you can certainly use the same queue, double-ended queue, for insertion and deletion. So that is very common. Insertion and deletion is very common. So it is done. And of course, you can see double-ended queue. What are the operations involved? Of course, you know, front and rear are two special pointers, are two special variables that are need to be present for double-ended queue. Of course, as you see in the figure, insertion and deletion of elements is possible in both the front as well as rear ends of the queue. So as a result, you can do 4 operations. What are these 4 operations? Look at the first one, insert front. insert front. In short, I call it as a I front. I front, which inserts the element at the front end, inserting the element at the front end. Same way, D front, that is deleting the element from the front end. So insertion, deletion, you can do it in the front. So how it is done, we'll discuss. And of course, same way, insertion at the rear end. So I rear and deletion at the rear end. So you can also certainly do. So insertion and deletion at the rear end. Same way, insertion and deletion at the front end. So these are the 4 operations one can perform with the double-ended queue. So in fact, double-ended queue is nothing but it's an array. So you initially write it as int of array. So maybe you can write it as dq. So you can certainly write dq of 5. So where 5 cell array is created, and of course one side you have the front, another side you have the rear. So front and rear certainly you can insert and delete. Same way you can insert, you can delete at the rear end. You can do the same thing. Okay, now we will work with inserting at the rear first. So insertion at the rear end of the queue. We'll see the program function, and we'll also check how it is working with animation. I have included lot of animation. I have included. Let us see. So initially, you know very well, when there is no element in the queue, what happens? Front and rear are having the value -1. Front and rear will have -1 when there is no element. So initially you have an element 16 to be inserted in the queue. So what happens? You check whether rear is equal to -1, because your program is insert rear. So you have to check whether rear is -1. So that's why you are checking. You are checking the rear is -1. If rear is -1, what do you do? Front is equal to rear plus 1. First you increment the front and rear by 1. You increment front and rear by 1, and after that what you are doing? Q of rear is nothing but this position, in this position, Q of rear. What you do? You insert the element. Element is your 16 element is inserted. Yes, that is. And finally what it happens? You will return from the function. Yes, it is gone. Now the state of your queue is having only one element, and of course I want to insert another element by calling insert rear function, and I use 56 now, and now you check whether rear is equal to -1. No, rear is not -1. Rear is equal to 4. Rear is equal to 4 means whether rear has reached the last element. You are checking. So no, if it is rear is reaching the last element, then definitely you will display a message. Queue is empty. Queue is empty. You will definitely display a message. Queue is empty, but it is not empty. So you check it is not empty. Then what do you do? Rear is equal to rear plus 1. You increment the rear, and Q of rear is equal to element. So the element will be stored in the rear position. So this is how inserting at the rear end. Now another time you call. This time it is 81. 81 again you check whether rear is equal to -1. No. Rear is equal to 4. No. So now rear is equal to rear plus 1. Rear moves to the next cell, and Q of rear is equal to element. So automatically the element stores. Next, you call again insert rear function with 77 and you check whether rear is equal to -1, no. Rear is equal to 4, no. Rear is equal to rear plus 1. You increment the rear, then Q of rear is equal to the element. Element is 77. 77 is stored. Yes, it is done. Next, again you call another time insert rear function and this time you pass 39. You check rear is equal to 4, no. Rear is equal to rear plus 1, increment the rear and you store the Q of rear is equal to element. Yes, 39 is stored. Now you call the rear function again. This time you are passing 42. This time you are passing 42. Now you check whether rear is equal to 4. Yes, rear has already reached 4. That is the indication that, oh, the queue is full. Queue is full. So definitely it will give you a message. It will not insert 42. Instead it will give a message queue is equal to full. So this is what insert rear function. And note down this. You can take the screenshot of this. This is the function that you need to understand when you are inserting at the rear end. Now, deleting from rear end, D rear. So deletion at rear end. So now we know very well the queue is like this. And if you want to delete, first thing is you need to check. So integer I is the integer local variable that is used to store the deleting element, and finally that I is returned. Okay. So before that, what you do? First, you check whether front is equal to rear is equal to -1. If front is equal to rear is equal to -1, it is understood that Q is empty. Right now, front is at 0, rear is at 4. So they are not equal to -1. Okay. So that means there are some elements in the queue, which means you can delete the elements. Yes. So you check whether front is equal to rear. That means if there is only one element, in that case, what happens? Front and rear will be pointing to same. So no, front is different, rear is different. So they are, that means many elements are there. So then in such cases, what you do? Return Q of rear first. Q of rear. Q of rear is nothing but rear is pointing to 39. 39 is the element that is to be returned. Okay, that is the element to be deleted. And what happens? Rear will decrement. After giving 39, what happens? Rear will decrement. So you see, 39 is given first, then it is rear is decremented. So that's why this particular statement is a post decrement operator. It is a post decrement operator. Decrement. So post decrement operator. So because it is post decrement operator, what happens? First it gives the value and later it decrements. Okay. So next state, you call it again the D-rear function. Now you check whether front is equal to -1 and rear is equal to -1. No. Is front and rear are in the same position? No, they are not in the same position. Return Q of rear, then rear minus. Q of rear will be returned and then rear will be minus. Decremented. So this is how it is done. Same way next time when you call the function once again, what happens? You check whether front is equal to -1 and rear is equal to -1. No, they are not. Front is equal to rear. No, that is also not. And return Q of rear and later rear you decrement. Okay, you take out rear and decrement the rear. And of course, next time you call again the D-rear function. So what happens? Check whether front is equal to rear. No. Whether front is equal to rear, no, and of course return queue of rear and decrement rear. So now observe, now there is only one element. So observe, now there is only one element, and front and rear, they are equal to the same index value, that is 0. And remember, since we are inserting and deleting using the rear end, only rear pointer will going to operate. Okay, so next state. Again, you call the insert delete rear function. You check whether front is equal to -1 and rear is equal to -1. No, they are not -1. Now, is front and rear are equal? Yes, they are equal. Then what you do? You store the deleting element in I. The deleting element is 16 and 16 is stored in I. And what happens? Front and rear is equal to -1. So you make the front and rear as -1. Later you return the I value. As soon as you return the I value, what happens? Both the I value is returned back, and of course it is deleted from the queue. And observe now, queue is empty, and since it is empty, what happens? Rear and front is equal to -1. Now again, if somebody calls a delete rear, so it checks whether front is equal to -1 and rear is equal to -1. Yes. So you can certainly display queue is empty. Yes. There is no element, you cannot delete it. So queue is empty. So this is about rear end. So inserting rear, deleting from rear. Same way, deleting from front. Okay, you have some elements. Look at here, some elements. Say for example, 3 elements are there. Now, if I want to delete from front, so first thing that I'll do is I'll check. Now, since you are operating the front, so what happens? Front, a variable will go into operate. So now it is not rear side, you are doing front side. Since you are doing from front side, the front variable or front pointer is going to operate. You check whether front is equal to -1 and rear is equal to -1. No. Is front and rear are equal? No. Then what you do? Return Q of front. Q of front is nothing but 16 is returned, and front is incremented by 1. So front will move by 1, that is it goes to the next cell because you are deleting. So observe now, it is first returned, then front is incremented to +1. So next, again you call another time delete front, check whether front is equal to -1 and rear is equal to -1. No. Is front and rear are same? No. And return d of front, dq of front, q of front, that is 56 is returned, then front is incremented by 1. Observe now the same thing. Yes, 56 is returned, then front is incremented by 1. Now rear and front, now they are pointing to the same element. Now let us see what happens. Is front is equal to -1 and rear is equal to -1? No. Is front equal to rear? Yes. In such cases, so you store the q of front in a variable I. So you see I is 81. It is then what you do? Front and rear, you move it to -1 because this is the only element you are having in the queue. Once this element is also deleted, definitely it is an empty condition. Empty condition means front and rear should be equal to -1, right? So let's you make front and rear to -1, and finally you can return the I value. Return I value. So it is 81 is returned. So this is how you can delete from the front. And whenever you are deleting from the front pointer operates. Now the last operation, delete from the front, again you call. what happens if front is equal to -1 and rear is equal to -1? Yes, in such cases, what do you display? You display again Q is empty and return. Now, insert front. So, inserting front. Okay, let us take the state like this. Some elements are there like this. Already some elements are there. Now, you call for inserting of front. So, you check whether front is equal to -1. If front is equal to -1, so that means the entire queue is empty. In such cases, what happens? This particular code will execute. If queue is empty. Now queue is not empty. And of course, when front is equal to 0, front is equal to 0 means if all the elements are full, so it is not possible. If front is pointing to 0, there is no element to the left of the front. So front cannot move left. So it is no element is possible. It will say Q is empty and it will return. If in other case, what it will do? Front is equal to front -1. Moves the front and then the element 42 is stored into Q of front. So Q of front element 42 is stored. You can see this is how you can insert. Now this is the state. Now you check whether front is equal to -1. No. Whether front is equal to 0. Yes. Front is equal to 0. Yes. And definitely insertion is not possible. So you can display a message. Q is full. Q is full message. So this is how insertion in front, insertion from the rear, deletion from front, deletion from rear is done. And based on the type of restrictions imposed on the insertion and deletion elements, the double-ended queue is categorized into two types. Input restricted DQ. So that means, so in input restricted DQ, what happens? It's a special type of double-ended queue. It allows the deletion from both the ends, but restricts the insertion only to one end. So that is input restricted. So insertion can be done in only one place, but deletion you can do it at both the places. So normally, if it is restricted, input is restricted, insertion can be done only at the rear end, not in the front end. Okay. Same way, output restricted DQ is again another type of queue that allows insertion both sides. You can insert in the front, you can delete from the rear, insert from the rear also, insert from the front also. But deletion, you have to do it only from the front end. It is only from one end. So normally deletion means by default, deletion will happen only from the front. So that is the type. So those are the two types are available. So that's the concept. And before we end, what we have discussed? We discussed about today what is double-ended queue. Double-ended queue is a special type of queue that allows insertion and deletion of elements at both ends. That is in the front also and from the rear also. What are the different types of double-ended queues? There are two types of double-ended queues. So they are input restricted double-ended queue and output restricted double-ended queue. So in input restricted double-ended queue, insertion happens only one end and deletion at both ends. Whereas in the output restricted double-ended queue, what happens? Insertion can be done at both ends, but deletion can be done only at one end. So this is what we have discussed today. And in the next class, we'll be discussing on exercise problems on queues. So it is very, very important. That is on chapter 7, we discuss the exercise problems that are given in the textbook. We'll work it out. And That's all for today's class. Thank you for your active participation, and all the class recordings, notes, everything is available in this particular website. Have a wonderful day.